Hi, this is Nathan Tintle. In this Learning Goal video, we will talk about how to follow up a test that uses the MADS statistic. We'll use the ambiguous prose data set to talk about this learning goal. The p-value from simulation with the MADS statistic is approximately 0.001, meaning we have very strong evidence of an association between the group you were in, whether or not you saw the picture, and if you saw the picture, whether it was before or after you heard the passage, and the response variable of your quiz score. If you use a significance level of 0.05, this result is very significant. So, in other words, we can say we have evidence that at least one of the groups is different from the others. If you told that to someone on the street, they'd say, well, now what? Which group is different, or which groups are different than the other? The typical strategy is once you have evidence that at least one group is different than the others, now go in and compare each of the groups to the others. So in this case, what we find when we compute 95% confidence intervals on the difference in the group means is that seeing the picture before is significantly different than seeing the picture after or not seeing the picture at all in terms of your quiz score. These confidence intervals are denoted with asterisks because they don't include the value of 0, suggesting a significant difference in the group means when comparing those two groups. A couple of comments about this approach. Really, the approach we're proposing here is two steps. The first step is to compute an overall p-value. If that overall p-value is significant, follow up by looking at each of the differences between the groups. If not, you're done. This controls the overall type 1 error rate. This general approach is typical, that is, following up a significant overall test by doing all of the pairwise comparisons. However, there are lots and more sophisticated options which control the post hoc, that is the follow-up type 1 error rate. So instead of using 95% confidence, you might think of it as changing that confidence level, which is going to change the width of the interval somewhat in that follow-up analysis. The basic interpretation and approach in those more sophisticated approaches is very similar to the one that we've shown you here, and you do need advanced statistical software typically to do those more advanced approaches.